Okay, we are looking at the last two lessons of Chapter 7, and we're going to combine them because they're both fairly basic and part of its review. So negative exponents and scientific notation. Okay, so we're going to look at using both negative exponents and scientific notation. So first, let's review the rules. Okay, so this is the definition of a number being raised to a negative exponent. Okay, if a is a non-zero real number, it's just a number, not zero, and n is a positive integer, okay, then a raised to the opposite of that integer is the same as 1 over a to the n. So what that means is if I have a to the negative third, that's the same as 1 over a to the positive third, okay? And that works because, let's look at our patterns here. We're going to use 3. So 27 is 3 to the third power. Okay, if I divide that by 3, this is going to give me 9, which is 3 to the second power. Divide that by 3 gives me 3, which is 3 to the first power. Divide that by 3, I get 1, which is 3 to the 0 power. Remember, anything to the 0 power is 1. If I divide that by 3, I have 1/3. Okay, notice how here I'm subtracting 1 each time. So 3 minus 1 is 2, 2 minus 1 is 1, 1 minus 1 is 0. 0 minus 1 is negative 1. If I divide this by 3, I get 1 over 9, which is 3 to the negative 2. If I divide that by 3, I get 1 over 27, which is 3 to the negative 3. So that's why it works. Okay, so basically what we're doing is we're saying, well, 3 to the negative 1, okay, 3 to the first power is 3, so 3 to the negative 1 would be 1 over 3. So we're just flipping it over. Okay, so let's look at this. Example 1, I have 10 to the negative 3, which is equal to 1 over 10 to the third power, which is equal to 1 over 1,000. 5 to the negative 4 would be 1 over 5 to the positive 4, which would be 1 over 625. Okay, because 5 times 5 is 25, times 5 is 125, times 5 is 625. This would be the same as 1 over 16 to the first power, which is just 1 over 16. Okay, so you take whatever's being raised to that negative exponent and you just move it. If it's like this, you move it to the denominator. If it's in the denominator, you move it up to the um, numerator. You're just flipping it over, but only the thing that's being raised to that negative. Okay, the definition of a to the 0 power. If a is a non-zero real number, the expression a to the 0 is equal to 1. 0 to the 0 power has no meaning. It doesn't exist. But if you look back at our pattern here, we got to 3 to the 0 power is equal to 1. It doesn't matter if 3 was negative, okay, it would still be just 1. So anything, positive, negative, fraction, decimal, whatever, anything to the 0 power is just equal to positive 1. Okay, all of the rules for positive exponents also hold true for 0 and negative exponents. Okay, so as far as adding the exponents when you're multiplying the base, it doesn't matter if they're negative or 0, it still works the same way. If you're multiplying an exponent, raising it to another exponent, it still works the same way you're multiplying. Okay, to write a positive number in scientific notation, you express it as a product of a number greater than or equal to 1, but less than 10, and an integral power of 10. So what does that mean? Okay, basically what it means is I'm going to have some number times some power of 10. Okay, and that number has to be greater than 0. Okay, so it's got to be positive, but it has to be less than 10. So it could be like a 9.999, okay, um, which is less than 10, times 10 to whatever. It can't be 0 though. It has to be greater than, it has to be 1 or greater. So it can't be less than 1. So my number here must be, if I call it x, it has to be less than 10, but greater than or equal to 1. Okay, so I can't have 0 point something. That would not be considered in scientific notation. So scientific notation, you always have one digit in front of the decimal. It's one digit between 1 and 9. You can't have it be 0. All right, so if my exponent is positive, it tells me that I'm multiplying, that I have a big number. And if my exponent is negative, it tells me I have a small number. Okay, so let's look at this first one. This I'm going to write as 5.8 because I'm allowed to have one digit in front of the decimal. 5.812. I don't have to do the rest of those zeros. Okay, times 10. This means times 10. Well, I multiply by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I count how many digits are after the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 to the 10th power. Well, 10 to the 10th power is 10 billion. So think about it. 5 times 10 billion is going to be 5 billion. Okay. Actually, it's going to be 50 billion. 5 times 10 billion is 50 billion. So this is where it makes sense. Okay. This one, let's think about this. Here's my tenths place, hundreds, thousands, 10,000s, 100,000s, millionths, 10 millionths, 100 millionths. So this is the same as writing it as a fraction of 100 million. 1, 2, 1, 2, 1, 1, 2, 1. Okay, so it's something like this. That's how I'm writing that. So this is the same as 10 to the 1, 2, 3, 4, 5, 6, 7, 8 to the negative 8, right? 1, 2, 3, 4, 5, 6, 7. That'd be 7. 10 to the negative 7. All right. So it would be 7.2 times 10 to the negative 7. Negative telling me that this is really a fraction. It's 72 over 100 million. Okay, and all you have to do is count how many spaces did you move the decimal point. So we started with this decimal point here, and we moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We moved this one 1, 2, 3, 4, 5, 6, 7. Okay, because my number is small, my exponent is negative, but because this number is big, my exponent is positive. This one, if we look at it at first glance, we'll say, oh, it's already in scientific notation. It's not, because the number in front of the decimal can't be 0. It has to be 1, 2, 3, 4, 5, 6, 7, 8, or 9. So I would have to move this decimal one space that way. But what do I do with my exponent? Okay, since my original number was less than 1, 0.4 is less than 1, I'm going to subtract 1. Okay, so this becomes 5 to the 10. Okay. If my original number was greater than 9, I would add 1. Okay, so if my original number is bigger than 9 or bigger than 1, I add as positive. If it's less than 1, I subtract as negative. So when I'm changing this, again, I look at this, I say, well, it was started out less than 1, so I would subtract 1. Okay, multiplying numbers in scientific notation. Multiply the decimal numbers and add the exponents of the powers of 10. Put final answers in proper scientific notation. Okay, so I'm going to multiply the 2.5 times the 6.0. So 2.5 times 6 is 15. For the exponents, I just add them. Now my answer is not in scientific notation because I have 2 digits after the decimal. So this is going to change to 1.5. And since 15 is greater than 9, I would add, and I move my decimal one place, I add it because this number was bigger, so I'm adding it, so this becomes 10 to the 6th. Dividing numbers in scientific notation. Divide the decimal numbers and subtract the exponent in the denominator from the exponent in the numerator. Put final answers in proper scientific notation. So in this case, it's 3.2 divided by 2, which gives me 1.6. So that's good news because that's already in the right order. Then this would be 7 minus negative 4. So 7 minus negative 4, which ends up giving me positive 11. So that would be 10 to the 11th power. Okay, because you're dividing. This is a very small number. You're taking a big number and dividing it by a very small number, which is going to give you an even bigger number. All right, so let's look at this, try this. Simplify. This is the same as 1 over 4 to the positive 3 and 4 to the 3rd power. 4 times 4 is 16 times 4 is 64. So 1 over 64. Here, simplify your exponents first. Here we would add. So 3 plus 2 is 5. And here we would then subtract. We would say, well, I can cancel out 4 of these, and I'm left with 1 on top. So that's just 8. So don't multiply stuff out if you don't have to. Here we have to take care of the exponent first. So this is the same as 4 over 3 to the positive 2. Notice that the 4 doesn't go on the bottom because it doesn't have a negative exponent. Only the 3 has the negative exponent, so it goes into the bottom. So that becomes 4/9. Okay, here, this one's fun. We're going to multiply first, and then we're going to divide. And we're going to wait until we get to the very end to put it into scientific notation. Okay, so 4 times 9 gives me 36. I add my exponents. 4 plus -2 gives me +2. So this looks like this. Okay, then I divide. 36 divided by 2 is 18, and 2 minus 5 is -3. Okay, remember scientific notation, you're allowed to have a negative. Okay, so this time, this is not in scientific notation. So I move my decimal one space. Since this started out being bigger, I add the 1. So this becomes times 10 to the -2.